Samantha lives 2 blocks west and 1 block south of the southwest corner of City Park. Her school is 2 blocks east and 2 blocks north of the northeast corner of City Park. On school days, she bikes on streets to the southwest corner of City Park, then takes a diagonal path through the park to the northeast corner, and then bikes on streets to school. If her route is as short as possible, how many different routes can she take? So if we have City Park, say it's right here, and so she lives, say 2 blocks west and 1 block south. So say she starts at point A here. Then her school is 2 blocks east and 2 blocks north. So she's going to B. And she's always traveling. Once she gets here, she's always just going across the park. So the number of different routes she can take starting here are, she could go up 1, over 2. She could go over 1, up 1, over 2. And lastly, she could just go completely over and then up 1. So there are 3 possible configurations here. But then over here, there are a lot of different configurations. So she could go all the way up and then all the way over. That's 1. She could go all the way over, all the way up. She could go over, up, up. That is, I'll tally them, 1, 2, 3. And then I'll make new ones here. So over, up. She could do up, over, up, over. That's 4. And she could also go up, all the way over, up. That's 5. And she could go over, all the way up, over. And so you think through, probably would have been easier to write all these out as separate patterns. But if you look at all these are all different patterns. And if I try to think, there are no other patterns I could make here. So there are 6 possible ways from here she could get to school. So the total number of ways she could get to school is, she has 3 ways to choose from down here. So it's going to be 3. And then she's always going up here. And then she has 6 ways to go to school once she gets here. So times 6. So her total possible different routes she can take is 3 times 6, which is 18. So the answer is choice E.